Hello and welcome to lesson 11-6 in the Big Ideas book. Today we're going to be talking about volume of pyramids. So what we have here is a prism and a pyramid, and they both have the exact same size base. So if I took this pyramid and put it on top of this pyramid, they're going to be exactly the same. And if these bases are the same, what about the volume of the amount of liquid? So the heights of these are also the same. So if I've measured the height from here down perpendicular to the middle, and I measured the height from the middle of this to the middle of the bottom one and measured down, those two heights are also the same. So not only do they have the same bases, but they also have the same heights. But obviously the pyramid goes up to one point and only has one base, and the prism has two. So how are these related? And in class, we would do a little experiment, and I would fill up the pyramid of water and I would pour it into the prism. So how many pyramids, how many pyramids of filling up with water would it take to fill up the whole prism? And usually people guess anywhere between 2, 3, and occasionally people will sometimes do 4. And actually what we find out by filling these up with water and seeing how they hold is that it is 3. 3 of these pyramids equals 1 of the volume. So if the formula for the volume of a prism is going to be the area of the base times the height, the difference is to go to the pyramid is we're going to take 1/3 of that formula. So remember that capital B stands for the area of the base. Okay, and the height is the height of the figure, so starting at the vertex and going down perpendicular to that base. All right, example number 1 here looks like we have a rectangular pyramid. So this formula is going to be 1/3 area of the base times height. So 1/3, and this base is a rectangle, so it's length times width, and then the height of the figure. So 1/3, and the area of the base is going to be 5 times 3, and the height of the figure is 7. So it looks like 1/3 is going to cancel off with 3, and we're going to end up with 35, and our label is going to be inches cubed. So it's that area of the base times the height times 1/3. All right, and this one, it looks like we're going to have 1/3, and then we have the base in this case is a triangle. So we're going to do 1/2 base times height times the height of the figure. So we have 1/3, and the area of the triangle is going to be 1/2 times 3 times 8, because those are perpendicular to each other, times the 5. All right, and if I did my math right here, this one is going to, these 3's cancel, 1/2 of 8 is 4, 4 times 5 is 20 miles, and we're talking about volume, so it is cubed. All right, third sample here. Oh, what is the height of a square pyramid? So whose base length is 10 and the volume is 400. So we have 1/3, our volume is 1/3 because we're talking about a pyramid, the area of the base times the height. And it sounds like it is a square pyramid, so its volume equals 1/3 side squared times the height. Now they're telling us that this volume is 400 and 1/3, and they're telling us the base edge length is 10. So we have 10 squared, and we are looking for the height. So 10 squared is 100. So the easiest way in my mind to do this is to divide both sides by 100. So that we take 400 divided by 100 is 4, equals 1/3 times the height. So now to get rid of the 1/3, we're going to multiply both sides by 3. And so we end up with 12 centimeters. So this is using the formula backwards. If they give you the volume, can you go ahead and find whatever piece they are looking for? And our last problem here is that we have a composite solid, so we have to have a plan. So basically I'm going to take the volume of the box, and then I'm going to add to it the volume of that top figure or the pyramid. All right, the volume of the box is going to be length times width times height. Looks like we have a square in the bottom, so it is 12 times 12, and then the height of this box is 9, plus the volume of the pyramid, so we're going to take 1/3, and now for the pyramid, that bottom is a square, so it's going to be area of the base is going to be side squared times the height. Well, we can fill in most of this, so we can do the 12 times 9, which is 1296. And then we can fill in that we know a side is, whoops, side's not 12, that side is, side's not 10, it is 12. Put in the wrong number there. 12 squared, and what we need to find is the height of this. So what we're looking for is this piece I'm drawing in now, if that's going to that figure and what this comes out, that this is going to be a right angle, so this is what we need, is this height of this figure. Well, we now know that this is 10, and if we know this whole thing across this box is 12, then I know that this piece down here is going to be 6. Well, this has to be a right angle down in here, so I'm going to set up 6 squared plus what squared is going to give me 10 squared. And so we've got 100 minus 36 is 64, so x squared is 64. So I think x is going to be 8. So I can go fill in the height of this figure is going to be 8. And now don't forget that this is 12 squared in here, not just a 12. And if we multiply this out, we're going to get 1680 meters cubed. So volume of this composite, add the box, plus the volume of the pyramid. All right, your homework is going to be on line 11-6.